Hello everyone, thank you for joining my session on dynamic programming. Here I am showing you a problem solution of a question of medium difficulty. Dynamic programming questions are not so hard if we know how to solve these subproblems, and this question shows you just that. So let me go full screen mode and talk about a solution I am trying to optimize right now. So I've I just solved this question right here, and just to give you a quick walkthrough of this question, a sample input involves a list of values of which you have to take a summation of non-adjacent numbers such that you are returning a maximum sum. So if I'm to add 75 with 120 and 135, that gives me a maximum sum of 330. To show you how this list of output can be built, I have given a quick exercise workout solution for one of the examples. Like if let's say there is one element, I'm going to have 75. If there are two elements, I'm going to have results to store two elements. If there are three elements, then I am going to at this step evaluate whether to take a sum of the previous non-adjacent element or just take what I already had and not choose 120 in the summation because it's adjacent, right? So I can choose to either keep 105 or I can take a sum of the previous number. And I've come up with this formula, and when I've got 195 as a total sum, this is obviously greater than 105, so combining 75 plus 120 gave me 195. So I kept 195 over 105, and I keep doing the same thing iteratively until I reach the end of the list. That said, let me move on to the solution part 2, where I am looking to optimize the previous solution. In this step right here, I have few hints here. I need to attain the optimal space and time complexity wherein I could get this question solved in order of one space. So what I'm currently using is a result list, and I don't want to continue to use the results list to store values for me. Notice the one thing that is odd is that I'm storing all the result values in a result array, but I don't need all of them. I only need the previous two values, right? So I need a mechanism or a design to systematically store the previous two values and be able to use them as and when I need them. With that said, let me try to fix that issue and see if I can get this problem to work and get a green output. Okay, so here is what I had in mind. I could get rid of this step, get rid of that, and array of 0, I can make it a just result. Okay, what would be a nice way to address two elements? I can call it result 2, and in a minute I'll show you why I'm calling it that, and I'll call it result 1. Now in this step you would have realized why I'm calling it 1. 1 is the recent most result and 2 is the older result, which is why I'm going to choose this notation. And this, by the way, should not be an issue as I'm not planning to change this right now. So for simplicity, I'm going to keep that, and here's what I'm going to update. This step is going to update a temporarily, I'm going to call it temp2, and this number here is array of I. That's not an issue. I need a old result and I need a recent result, and that will give me a temporary solution, right? And it's nice that I have a temporary solution now, but I have to also update the previous values because it should make sense to update them, right? So the recent one that I have is previous 2 should take the value of previous 1, and previous 1 should take the latest value of temp, because these numbers need to be moving. What I'm not sure of is whether this works. So result 2 should take the result of result 1. So I'm just moving result one step ahead, and I'm going to move result 1 to current step ahead to store the temp value, because these are the only values I'm going to need. With that in mind, what could be the result for this thing? I think what I need to return is result 1, because result 1 has the latest value stored at its location. Now that is done, but I'm not very sure that I've got a solution for this. Oh wow, I have a nice tool here, so I'm going to start it. Wow. Oh, this is nice. Okay, we'll try that later. What's this? What this? Wow, wow, wow. Okay, there are nice things here. I'll check them later. 75 results. 75, 105, 75, 105, 105, 75, 105. Okay, so then I can make it result 1, and this is result 1, and this is result 2. So there's result 1, result 2. I've modified this. Okay, am I storing in the same way? Alright, so you see, initially I can just have result 1, result 2, and just store 0 values for them. I see that there's one problem. I need to return maximum of result 1 and result 2, because there might be just limited elements, so what's the point, right? Okay, so there was this problem. I got rid of that. And then at this stage, what happens to the result 1 and result 2? But let me see. The result 2 should be 105, and result 1 should be 195. So then similarly, here I should have result 1 and result 2. So both of them should store the same numbers for me, because they are just one element. They're the same elements, right? So so far it looks good. We need to try with an example. Quick test we can do from here. Just run the code. You shouldn't do that, but this works. I'm going to try with an empty list, and that gives me a solution. I've got 1. Does it work? Okay, that works too. I'm going to put one more element. Does that work? Okay, that works. One more element. Does that work? Yeah, it works. Okay. I'm going to put, I don't know, a bigger element. Does that work? Okay, it seems like it looks like it works for a lot of solutions. So I'm going to try. And that's the solution there. So just now you saw how we can improve the time and space complexity, the space complexity for solving a dynamic programming question. So to recap, earlier we used a list to perform the optimization and save the results, but now we have used variables called the result1 and the result2 and returning the variable results to finalize final output. Okay, so thanks for watching.